Hi students, welcome back to my channel. Today let us learn about Fajan's rule, another concept of electronegativity in elements. This rule predicts whether a chemical bond will be covalent or ionic. A few ionic bonds have partial covalent characteristics, which was discussed by Karimedes Fajans in 1923. The Fajan's rule is based on three factors. The first one is size of the ion. Smaller the size of the cation and larger the size of the anion, greater is the covalent character. First, we'll just go through the content and then we will learn in depth. Second, charge of the cation. Greater the charge of the cation and is the greater is the covalent character of the ionic bond. Third, electronic configuration. The cations with same charge and size with n minus 1 d to the power of n and ns to the power of 0, that is usually the transition elements, has greater covalent character than those of alkali metals with electronic configuration ns2 np6, which is usually found in alkali and alkaline earth metals. Because transition elements usually have pseudo octet configuration, means their outermost electrons are outermost shells are not completely filled. When the outermost electrons are not completely filled, the shielding effect also decreases, and because of this the covalency gradually increases. The first one, polarizing power of cation. If the cation is smaller, then we can say that the volume of the ion is less, the charge density of the ion is high, and this makes the compound more covalent. So we're already aware that when the cation is smaller, then their nuclear power will be larger. Okay, so when their nuclear effective nuclear charge is more, then it means that they can attract the larger anion towards them. So when they attract, there can be an easy covalent bond formed. Okay, so that's the first criteria, that is the polarizing power of cation. Means cation must be smaller, then there is always chance for covalent character. So example, if I take MgCl2 and compare this with NaCl, then what happens is Mg is atom cation is smaller than Na. So Mg has a higher capability of forming a covalent bond compared to NaCl. That's why we usually know that NaCl is an ionic bond, right? Whereas MgCl2 is a primarily a covalent bond. So here Mg is quite a smaller cation and Cl is quite a larger anion. So here there is an equal energy attraction, positive and negative attraction, that is nucleus and electrons. Hence there is a covalency formed in MgCl2. The second criteria is polarizability of the anion. Larger the anion, less effective is the nuclear charge that holds the valence electron of the ion. Hence, valence electron can be easily polarized by the cation. So this is again the second criteria, wherein the anion must be larger. When anion are larger, then the valence electrons will not be in control of the nucleus. So when the valence electrons are loosely placed, then easily they can get ionized. The electrons can easily get ionized, and that is they can get attracted to the cation, and this also permits the covalent character. The last one would be pseudo octet or pseudo inert gas configuration, is when an ion has 18 electrons in its outermost shell rather than the usual 8, achieving stability by filling the s, p and d orbitals, common in transition metals like Ag, zinc ions, contrasting with true noble gases having only 8, that or 2 for helium. This configuration helps in formation of the covalent character. So as I already told you, in alkali and alkaline earth metals, the covalency is less found compared to transition metals. In transition, it's rather more found because of their pseudo-octet configuration. Because of the pseudo-octet configuration, what happens is metals, usually they are highly, that is electron withdrawing. Cations are highly energetic and they are electron withdrawing. I mean, they attract the electrons towards itself, and hence there's a larger chance for covalent compound to form. So these three are the reasons of Fajan's rule. Thank you for watching the video and please subscribe to my channel.